as we already mentioned that one of the key architectural benefits of Data Vault is they can handle the changes flexibly compared to 3NF and dimensional modeling approaches. And the main component in here is the link table. So in this session, we will discuss it with a couple of examples. But first, let's refresh our memory about some fundamental rules of the link table. We use the linked entities for modeling transaction and associations. So in a way, link table captures the past, present, and future relationships between the different entities. But links does not store any timeline like adding a start date or end date columns which force this relationship in a single timeline. Therefore, it is important that links do not end dated and contain no other time or context information except a load date. Links represent a relationship that currently exists or one that existed in the past. And another rule is Data Vault links represent always many-to-many relationships, and it proves quite flexibility as even the business rule changes, or if we need a different cardinality between different entities, then we don't need to change the link tables because it is already including many-to-many relationship. So as we see that link tables has already have flexible structure as it is include a general cardinality as many-to-many, and it does not also limit the relationship with a timeline. But data warehouses are live systems and business requirements or rules will change over time, and these changes will impact the existing model and requires additional maintenance effort. In order to get better idea, we would categorize these changes as schema and granularity changes. So let's understand more with some real scenarios. Suppose that we have source tables in operational system that show student information and class details which they are enrolled. As you see in here, there is a primary key foreign key relationship between these tables. Primary key of class table takes place as a foreign key in the student table. So now we can see that how this relational model is transformed to Data Vault structure. In the right side, first we identify the entities which in here student and class tables, and also find out the business key fields, their student and class ID columns. Then based on this information, first we create the two hub tables for student and class. Then as a next step, the primary key foreign key relationship in the source tables shows that we need a link table between these entities. And finally, satellite tables that include the descriptive information of student and class is also attached to relevant hub. I just presented satellite tables with an icon instead of showing table details because it is not our focus right now. Okay, now our Data Vault model is ready. But think about for a while later, the school organization has initiated social clubs that students would like to join, like chess, dance, music, or photographer. And now school management would like to report this information as well to see how many students registered to clubs. So which students are interested in dance club or who joined the music club, so etc. That shows that we have a new table as club and also needed to integrate it with the student information. So think about how we will handle this change in dimensional and 3NF model. As you remember, in dimensional model, we have a fact table which is surrounded by dimension tables, and each primary key fields from dimension table are embedded into the fact table. So in that case, if we would like to involve a new table, that means that we need to change the granularity of the fact table. So either we will create a new fact table or we will modify the existing table. Because the historical data is stored in the facts and dimensions, that leads to major issues when there is a change in business rules, as it is not easy to change or add particular entity without losing or corrupting the historical data. And on the other hand, with 3NF model, complexity became with the parent-child relationship. So in case of we made any change in the parent table, it rippled through to underlying tables. So when the cardinality between tables change over time due to new business requirements, whole structure has to be changed in the 3NF. In both dimensional and 3NF models, it is also requires a big upfront modeling exercises before development can start, and changes along the way are very difficult to implement as it requires complex ETL and rework processes. Against this, as the link ensures the scalability of the Data Vault model, it is possible to start with a small Data Vault model for the data warehouse and extend this model by adding more hubs and links to create a larger model. Okay, now back to example and see how we will implement this change in the Data Vault structure. Club is a new entity and has its own business key as Club ID, so that directs us to creation of a new hub for the Club table and insert all descriptive attributes into satellite table, and also create a link table in order to provide relationship between Club and Student Hub tables. So now we integrated the changes to the model, and there is not any change in the existing structure of the Data Vault model. Okay, then look at the second scenario. We would like to integrate student address information into our model. So the table includes student ID and the address columns, and suppose that the business key for the address table is the student ID. You may notice in here that the business key for student and address tables are the same. And we already stored the student business key in the student hub table. So in this scenario, we don't even need to create a new hub or a link table that integrate it to another hub. So we can simply create a new satellite and join it to the existing student hub. So in general, if you would like to do any change into our model, and if the business key is already exists, we can just simply create a new satellite table and integrate into the hub which contains the existing business key. Okay, now we have another scenario. In here, student table in source system is extended with an email column. So look at how we will adapt this change into Data Vault. There is mainly two approaches in here we may follow. First one is if our satellite table is small, so we would modify the satellite by adding the extended column. But it has some drawbacks, as if your source system does not historize data, as most likely not, because operational systems mostly focused on fast insert and update operations, they don't store the history and you may lose the data in here. And another approach is you may create a new satellite and involve the email information in here and attach to relevant hub. In 3NF or dimensional schemas, this would cause a major change to the student dimension tables. But within the Data Vault, this could be handled with either a new satellite or change the small satellite table containing the related data. So again, we see that the data model is not impacted due to these changes. And the last one is change in granularity. But first understand what is the granularity. By granularity, we mean the lowest level of information that will be stored in the link table. It is defined by the number of hubs that they connect. In our example, we mostly connected 2 hubs with a link, but it connects 2 or more hub tables. Every time a new hub connected to link table, a new level of grain is introduced. So the more hubs a link connects, the lower granularity it becomes. In this way, links behave like fact tables in dimensional model. So when a new dimension is added to fact table, the granularity is lowered as well. But what would be the reason in change of granularity? Suppose that the school management wanted to see the grades of students during the exams they are getting in the classes like mathematics, chemistry, or science. As first step, we create a hub table for the grade information which include the business key of grades, and would attach a satellite table to grade hub that include the descriptive information about the grades. For example, A+, B, C, or 1, 2, 3, something like this that describe the grading system of the school. I didn't detail the satellites in here. So now think about that. We need to integrate grade information into this model. But how we will do it? I cannot simply create a link table and connect with student or class information, because grade value is not only relevant to student or class, it is a result of student and class relationship. So I need to find a way to bring all this student, class, and grade information into same link. So in a way, I'm changing the granularity of the link. So let's see some approaches to solve granularity changes in Data Vault. The first one is we could modify the existing link and add grade information that reference to GradeHub. But this approach is not acceptable anymore in Data Vault 2.0 because this would require re-engineering existing ETL jobs and also assign null values to the records which exist in the link table before restructuring. And another approach is the model can establish a new link between student, class, and grade. Then we will close the old link. Closing the link means that no new data is added to this link table anymore. Instead, new data is assigned to new link. We simply merge this old and new link information on the information mart layer. So as you see in here, we covered multiple scenarios, and for each of them, we would extend the model without doing any change in the existing structure. So the flexibility and adaptability are one of the most powerful features of Data Vault. As we earlier mentioned that you would start to design a small Data Vault model and extend this model by adding more hubs and links to create a larger one. Thank you for listening.